Hi everyone, good evening. How are you all? I'm Dhwani from Geeks for Geeks and I will be the host for today's session. We're really sorry for the delay that was caused. There was some network glitch at our end, and seeing a lot of people here, I'm really sure that we will all have a great session. You feel free to type in the questions that you might have during the session, and then I'm sure the mentor will be more than happy to answer your questions. So it is an honor for me to welcome Mr. Amit Kumar. Hi, Amit. Amit, are you there? Amit, are you there? I think if I'm perfectly audible and visible, can you all just send a thumbs up in the chat box so that I know there is no network glitch at my end? Just type in a thumbs up in the chat. Yeah, so hi, Amit. Amit, can you hear me?
Yes, Dhwani, you are totally audible to me. Am I
Great.
audible?
So, hi, how are you? Yeah, you're perfectly audible. How are you?
Okay. I'm very fine, Dhwani. Thanks for
It's
hosting
really
me.
great to have you here. It's really great to have you
Okay,
here. So, I would like to take up this opportunity to welcome you to introduce yourself.
okay. So, hello everyone. Myself Amit Kumar. I have done my engineering from Delhi College of Engineering, and I have been part of companies like Samsung, PayPal, and I'll be joining Microsoft soon. I have mentored around 200 plus students in attaining their dream job, and I like to teach data structure and algorithm. And I have done a lot of contribution in terms of data structure and algorithm. And I'm looking forward to help you all in whatever manner I can.
That's really great to hear. I'm sure everybody will learn a lot from you today. I have my copy and pen ready with me so that I can get the maximum out of this session. So Amit, you can present your screen now.
Okay.
Great. Another reminder, all those who are watching this session, you can always put your doubts in the chat, and I'm sure Amit will be more than happy to answer your questions. Let's try to make this session very interactive so that we can all learn something from Amit. So, Amit, I can see your screen. You might want to shift the tab to wherever you want
Okay.
to teach.
Okay. So I think everyone is comfortable with Word.
Yeah, I think so.
Just a minute. I need to. Just a minute.
Okay, not a problem. So till the time Amit configures his system, you can all type in the chat like what is your experience with data structures. I'm sure there are a lot of people who have a lot of experience with data structures, and there are beginners as well. So you can share in the chat box what has been your experience with data structures. Which data structures do you find the most difficult or the easiest? I'm sure it will be great to be able to communicate to each other via this chat box.
Hello. Am I audible?
Yes, you're audible.
Okay. Is my screen visible now?
Yeah, it's visible.
Okay. So I guess
I'm sorry,
will I
Amit,
be
you
able to
might
hear
want to
people
use
what
a
they're asking, or
different
I have
color.
to go to?
You might want to use a
Okay.
different
I'm just
color. It
checking
might
it
not be
because
visible.
it's a different.
Yeah.
No. Actually, I'm just checking it because it's a different laptop, different setup. Just checking
Okay.
it.
Right.
Yeah.
People won't be able to hear people. You won't be able to hear the people, but at the end, we can always take up the questions that are in the chat.
Okay, okay,
Okay.
okay,
Okay, so all the best.
okay. Yeah. Okay, thank you. So now today our topic for discussion will be sorting, and it is one of the most famous topic as far as any interview is concerned, or any college, or any important event is discussed. So I would first like you to introduce what is sorting. Like in our childhood we have heard about ascending order. What is ascending order? Sorry for the writing thing, because it's a new pad, I'm getting comfortable to it. So one is ascending order. So what is ascending order? If we have any number like 9, 6, 7, and I ask you to arrange it in a ascending order manner, so it will be 6, 7, 9. Super easy. So in our terms we call it sorting. Sorting is nothing, just to arrange it in a ascending order format. So we have different kind of things that we do using this thing. In childhood it was super easy to do this thing this way, but now in our world we want computer to do these things for us. So definitely we would be doing something for the computer so that it can solve any problem to us. For example, if we have number 9, 2, 3, and 5, and we want our computer to solve it in ascending order format. So first question is, in which data structure would you like to store it? Can I get answers in my comment section? Like, if we want to store any number to get sorted, which is the data structure that we would like to get it arranged in? Am I audible to everyone? Okay, I'm
Yes, you're
working on
audible.
data structure. Okay. So for these things, we have different data algorithms to do it, and we will be going from first one to second one. So whenever we talk about any sorting thing, first algorithm for us is bubble sort. So this is actually a sorting algorithm in which, let me take a new slide for it.
Amit, you can increase the size of the
Yeah,
eraser,
yeah,
I
actually
think.
this is a new setup. Actually earlier I was using my own tablet for it, so I was pretty much
So you
comfortable
can
with
use
it.
the
In next,
Jamboard,
yeah.
I guess. You can
Yeah,
use
yeah,
the
yeah.
Jamboard.
Where will it be available?
You just have to type Jamboard in Google and it will open up.
Okay, 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 okay. Jamboard, right?
Yeah,
Is this?
yeah.
Okay. Just a second.
Sure, not a problem. You all have different experiences with the various sorting techniques. I can see that in the chat box. I'm sure Amit will cover most of the uh, sorting techniques in this session. So you can always put in your questions and like some very specific questions. I mean, quick sort, explain quick sort. It's not a very specific question. So you can put in some very specific questions like what is the time complexity, how to manage the time complexity, and something like that. And I'm sure Amit will be more than happy to help you all.
Yes, I'm back. Sorry for it.
Are we good to go?
So, yeah, yeah, definitely. Just 1 second.
Sure.
Is my screen visible?
Yeah.
Okay. So, okay. So, we know actually we keep under consideration three things when we are using sorting. First is time complexity of any algorithm that we are using. Second is space complexity. And third is very important thing which people do miss out, but it's very important. Either it's a in place or not. It is very important thing asked in companies like Google, Microsoft, etc. I'll talk about it. So we will talk about first bubble sort, because it is the basic step that we do use in sorting algorithm. So in bubble sort, what we do, if we have any number like 9, 6, 3, 4, we check for adjacent element indexes. For example, this is 0th index, this is first index, second index, third index. First we will check for any two indices. For example, 0th index and first index. Is 9 bigger than 6? Yes, it is. So here we will swap and it will become 9. Similarly, is 9 bigger than 3? Yes. So now again we will swap. It will become 3 and it will become 9. Now again we will be checking whether 4 is smaller than 9. Yes. So here it will come 4 and here it will come 9. So after this iteration, what will happen? We will be having an array of 6, 3, 4, 9. So here one thing happened, like the biggest element automatically came to last part of the array. So the biggest element is 9 and it came to the last element. So this part is sorted. If you see this array into two part, now this becomes unsorted part of the array and this became sorted part of the array. In next iteration again we will do this thing. Is 6 bigger than 3? Yes, it is. Then 3 will come to here and 6 will come to here. Now again, is 6 bigger than 4? Yes, it is. So 4 1 come here and 6 will come here. Now in this, after this iteration, what happened to us? Now we have a array of 3, 4, 6 and 9. And in this array, if we look at it into two parts, this part is unsorted and this part is sorted. So our sorted part is increasing into this direction and we are getting a sorted array here. Now in the remaining part we will be checking, is 3 bigger than 4? No, it is not. So we will not swap and we will come to this part, and this is the end part of the array. So what happened to us? We automatically got a sorted array in this situation. In this array, what we were doing, at each iteration we were checking for elements whether that element is smaller or bigger than the previous element or not. So here, what would be the time complexity for it? Here we are already checking for every element. So here we have time complexity average, worst and best. So whenever we talk about any time complexity, we take about average time complexity. So it would be of O of n square order, because here in first iteration we will be going n times, in second n minus 1 time. So in if this kind of any pattern is formed, then the time complexity of O is O of n square. So this is will be the time complexity for bubble sort. And in bubble sort, what we are doing, we are trying to make two array. First one will be unsorted and second one will be sorted, and the size of the sorted array will be increasing by 1 in this manner, and then this, and this part will always be sorted. So this would be a pattern forming, and it will be an algorithm in which we will be getting a sorted array for our cases. And if we talk about worst case time complexity for it, it would be of O of n square only. But what would be the best time complexity for it, for the best case? And if we talk about best case, in best case, what might be the array? If the array is already sorted, for example, array is 1 2 3 4, here it will check for this: is 1 smaller, yes; 2 smaller than 3, yes; 3 smaller than 4, yes. Then in that case, the time complexity will be O of n, because in that scenario we have to do only checking for the one time iteration. So here the time complexity would be O of n in that case. So if we talk about bubble sort, we are able to get a sorted array, but the average time complexity for it was O of n square. And I think it's not one of the good. And many of you must be using function called sort whenever you use any programming language. And for example, in C, sort array comma array plus n array n plus, then it automatically sorts array. So I'll be coming to that point, like which algorithm do they use to sort array. But if you talk about bubble sort is one of the most basic algorithm used to sort any array. So if anyone has any kind of doubt in this, like any doubt regarding to bubble sort, then I can do it again, or next I will move to another sorting algorithm which is very famous and which is very widely used. Anyone having any doubt in bubble sort? Okay. Okay, for best time
Amit, I
complexity
think
of n, because if the array is already sorted, then it will check for one time, and at the last iteration it will become O of n. So in best time complexity for bubble sort, it would be O of n. Space complexity remains almost same for every, because here we are not using any external space, we are using only the array of the space, so that we will not be using any extra space for this. Okay, for Java, no, I have used only pseudo code. I haven't used any programming language as of now. It was a pseudo code that was written.
Amit, I
Uh,
think it would be great if you
like
explain the
space,
algorithm
here we do
also.
not swap. No, for bubble sort, it would be difficult. We can do it, but for that we have to use another extra array for that. I might discuss it later. Okay. It, yeah, we can do, but for in place it is actually in place because we are not doing it. So okay, any other topic regarding to bubble sort? Yes, the worst time complexity would be O of n square, because we will be iterating every element for that. Like every element is not sorted in that array. So we have to go to each and every element and then sort it. Any other doubt for this? I would like to ask one question which was not asked. There is one thing called stable and unstable. So according to you, is this algorithm stable or unstable? Stable and unstable is decided on the basis of whether we will be using extra comparison in it or not, whether the location of every element will be same as of previous or not. So whether it will be stable or not stable, anyone who can answer it? Okay, great. Yeah, it will be stable because we will not be disturbing anything for that. Okay, great. I think most of the doubt for the bubble sort is clear as of now. We can move to next topic, which is very important part in it, and it will be selection sort. Selection sort is very important technique which is used widely, and selection sort is a bit confusing at starting, because here we choose the minimum element and then we swap it to last part. So be attentive if you are doing it for first time, because it's very interesting to understand if you haven't done it yet. So it will be selection sort. For example, if you have a array 9, 2, 3, 6. Earlier, what we were doing, we were comparing these two elements, and the bigger was coming here. Then these two elements, and the bigger was coming here, and these two elements, bigger was coming here, and we were getting the last element as the sorted element. Now, what we will be doing, we will be choosing basically a element from it, which would be the minimum of it. So here, what we can do, like here 9, 2, wait a minute, 9, 2, 3, 6, we will be taking a variable called minimum, and we will be assigning any array of 0 to it. I am writing it, it might sound confusing at starting, but it's very interesting. For example, we have assumed that 9 is the minimum in the array. I think there is no problem in doing things. We can assume things like 0, 1, 2, 3. Now we will come to the next element and we will check, is 9 the minimum element in the array? Here 2, which is less than 9, true. So now if next element then is smaller than 9, then will 9 be our minimum element? No, now our minimum element will become 2, right? Now we are not sure whether it is the minimum element in the array or not. We will moving to next element and we will check, is 2 smaller than 3? Yes, not a issue. Then still also our minimum element will be 2. Then we will move to next element to cross check whether it is minimum in the array or not. Is 2 smaller than 6? Yes. Now we have reached to the end of the array. Okay. And still also our minimum is 9. Okay, not a issue. Then is 9 is 2 the minimum element? Yes. So what we can do, our 2 will come to starting part. Okay, we can do that. There is no issue. And then we will be having element 9, 3, 6. Now what we can do, we will make this part as the sorted part. This part is sorted because it is the minimum element. You will check, we have picked nothing. We have done in school assembly, you have seen na, ki the person with the minimum height is being selected, like yeah, this one is smaller, then you should come in the starting. Similar, it is a line and we have picked the smallest element in the array by comparing it with every element, and we have put it into the front of the array. Now we will do it for again things. Minimum is 9. Okay. Now is 9 the minimum? For next element we will check, is 9, was the 9 the minimum element? We will get no. We have a smaller element which is 3. Then in that case we will update 9 to 3, and then we will do the thing again and we will check, is 3 smaller than 6? Yes, we have found. So still also the minimum is 3. So what our array would look like, our array would become 2, 3, 9, and 6. Not a big deal in it because it was the thing that was happening. Now if we look at the array, this part is sorted because here we have element in increasing order, and this part is unsorted. Now here again we will take minimum as the 9, first element of the unsorted part, and then we will keep on checking it. For next element, is 6 smaller than 9? Yes, obviously 6 is smaller than 9, then our minimum element will become 6. And then after that our array would look like 2, 3, 6, 9. Now this was sorted and this was last element was unsorted, and if we have only one element, it is always sorted. So now what our array would look like, it would become 2, 3, 6, and 9. And this is actually a sorted array which we wanted. So what we were doing in selection sort, we were picking minimum element from the array, minimum element from array, and putting it into front, and putting it into front, and repeating this process again and again. And we were getting a sorted array for this case. And so what would be the average time complexity for it if we talk about this? So it might be a case that the array is non-sorted, and if it is non-sorted order, for example 9, 8, 7, 6. So for this thing, we have to first take 6 into front, then 7 into here, then 8 here, 9 here. So here average time complexity for it would become O of n square. Okay, because in worst case scenario, it might be possible that it is in this scenario, and average test case scenario for this would also be this. And the best thing is this: in best case time complexity also, it would be O of n square. So all the time complexity for selection sort is n O of n square, because we would be doing comparisons to do this. So the time complexity for it would be O of n square, and we are not using any extra space. Actually, there are only one or two algorithms which where we need to take extra space, and otherwise we do not need any kind of extra space to do it. So the time complexity for it is O of n square. And okay, whether it will be in place or not, or whether it will be stable or not, this is my question to you. Yes, Karan, it is actually a swap, but here swap is based on whether which is the minimum element in the array. We will be doing minimum, we will be choosing minimum element in it, and we will be taking it to front, and then that part would be sorted, and we will be doing these steps again and again. Who are saying stable? Why it would be stable? Won't it be unstable? Because we are changing, swapping things again and again. Okay, I'll again I will explain you what is stable and unstable. Apart from it, whether it will be in place or not. If anyone knows what is in place, whether it will be in place or not. Just give it a try. You might be wrong, but giving a try is always good. Okay. Yeah, we can do, Karan. We can choose the maximum element and put it to the end. This is also a selection sort. No, no, we can do. Karan is right here. But for that, we have to iterate array from back to front, not front to back. Okay, I think is this sorting technique clear to everyone? Because I will change only a little change to it, and it would become a very famous question that is being asked in interviews. Okay, I think this question is clear to everyone, like how to do. Like now, if I say write a code for selection sort or explain me selection sort, most of the person would be able to tell and write it down. Keys, choose the minimum element, put it into front, and do this for the rest of the array, and you will get a sorted array. Okay. Now there was a question asked in Google interview, and it was written into a different way, and people were not able to identify it's a problem of selection sort. The problem was write a sorting algorithm which never take more than n comparisons, more than n comparisons. It was like write a sorting algorithm which never take more than n comparisons. And what is interesting part about it, it is selection sort, because in selection sort, if we have one, two, three, four, five elements, how many comparison do you think will it be needing to get it sorted? Write in the chat box for 1, 2, 3, 4, 5. How many comparisons will be needed to sort it? Okay, for example, here minimum will be 1. It is already sorted. Then for 2, we will check it. For 3, 4, 5, we will check it. 4, 5, and 5. Only 5 comparisons will be needed to sort the array. So selection sort is asked in this way: ki write a sorting algorithm which never take more than n comparisons to sort, and only sorting selection sort can do that in that way. So selection sort is basic, but if you ask this question in this format, then it become very famous product based companies question. So product based companies do ask questions in tricky way, but the solution is very basic. That that we need to apply there. It's the way how they are forming the question out of it. So this is how it is done. I think these two sorting algorithms are clear to everyone. Now I would move to another very famous sorting algorithm, and people find it a bit complex many time to understand. And wait a minute. Yes, at most it will take n comparisons. You guys are right. So now one of the most important sorting algorithm is merge sort. And in college, universities, and different places, this question is straightforwardly asked. And even in companies, this thing is used because this is the sorting algorithm which takes extra space to solve. And using extra space is actually a expensive task, but many times it's very much needed. So I would like to draw a diagram for it. For example, if you have this box, sorry for this. Okay, if you have this box and you break it into two half, okay, break it into two half, and then again break it into two half, a time will come where only one element would be in it, like 1, 2, 3, 4, 5, 6. Then here 1, 2, 3, 4, 5, 6. Here assume it's 1, 2, and 3 here. Here after it will come 1 and 2. Yes or no? Here 4, 5 in this box and 6 here. After this it will have 4 and 5. So after one level you will notice there are only one element in everything at this level. And you know everything, if there is only one element that is sorted, so what we do, we sort 1 and 2. It's automatically sorted. Very good. 3 is already sorted. Then we have now two box 1 and 2. We'll sort them back and it will become 1, 2 and 3. Now we will come back here, we have 4, 5. What we will do, we will sort them. Yes, 4 is smaller, 5 is bigger. So we will be having a, sorry, we will be having a box again where we have 4 and 5. After that we have 4, 5, 6. We will come back to it 4, 5, 6, and that at one end it will become sorted. I took sorted array so it becomes easier for you to understand what is happening, because if logic is clear what is happening, then we can make it complex and then do it again to understand it better. So here what we do, we break down things into smaller pieces and we try to merge things so that it becomes sorted. So first we break them and then we join them, joins in such a way that it becomes sorted. So it's called merge sort because we are merging things in another flow. I will explain you with another example for it. In merge sort, what do you think? Will we be needing any kind of extra space to do it or not? Because we are trying to break things into smaller pieces and then we are trying to merge it. Take unordered. Okay, I will take it. We have 9, 2, 6, 4, 5, 8. This is a array that we have. Okay. Now what we will do, we will break this array into two parts. First we'll have 9, 2, 6. Another will have 4, 5 and 8. Okay, not a big deal. Now we will again break it. First part will have 9 and 2. I am taking one extra element in first part. You can take it in any way, in first box or second box. Both the way are right. In this we will be having 4, we will be having 8. Now after this we will be having 9, we will be having 2. These will be single elements, right? After here we will be having 4, we will be having 5. In last I am making it circle, so it becomes easier that there is only one element in it. Okay, so now we have different kind of single elements in our things. Now if we want to merge 9 and 2, because there are only two elements, we can compare which one is bigger, which one is smaller. 9 is greater than 2. So in this, when we come upwards, it will become 9 will be removed from here, and we will be writing a sorted way to it. So here we will be writing 2, and here we will be writing 9. Okay, because we are now arranging them in a sorted manner. Now, and again upward move for same level thing. Here it is 4, here it is 5. So now is 4 smaller than 5? Yes, it is. So our array would look like this. 4 is smaller than 5. Okay, and then in 8, this level we are in, till this level we have tried up to our standard. Now in upper part, we will have two different smaller uh, sub part of array, and now we need to sort it. So 296, what is the right way to write it? We will be writing that into that way. So it will become 269, and here we have 4 5 in one box and 8 in another box. Okay, when we move up to it, it will become 4 5 and 8. Okay, great. Now we have this array as sorted array. This part is sorted, and another box that we have, that part is also sorted. So basically we are merging two sorted arrays to make a final sorted array. So this part is sorted like 4 5 8, here 2 6 9. Then in upward move, what we need to do, we have two sorted arrays, and we need to make it in a such way that final array is also sorted. Okay, great. So in this array, what our final array would look like? So minimum element is 2, then we would check the next is 4, then next is 5, then next is 6, then next is 8, and then next is 9. So this would be the final array that we would be getting. All of the code is available on Geeks for Geeks in C++ and Java also. So that's why I'm not writing the code. I can write it down and then give task to you to compile them and then solve it. But here we are just trying to understand what is happening in the algorithm. So in this way we can get the final output array. Is this example clear, like how we are trying to merge two arrays? Okay, so in this way we can try to make things break into pieces, and then we can try to merge them in a way so that every part of the array is sorted in each iteration, and then in the final part the array becomes sorted. Any doubt for it? So I can ask, like, what would be the average time complexity for merge sort? Anyone who can answer? It's around 2 seconds. What would be the time complexity for merge sort? Anyone who knows? Any average, worst, best case time complexity? Okay, so let me tell you, it's n log n, and this is one of the best time complexity that we can do things in. N log n, average case time complexity is best time complexity that we can sort any algorithm with. Many people would be asking, like, why log n? So it is like whenever we are doing things like n plus n by 2 plus n by 4 plus n by 8, if anyone remembers, it's actually expansion of log of n. So first what we did, we were having a array, complete array, then we broke it down into half, right? So we have array into 2, then again into half, so n by 2 into 2, so it became n by 4, again then half, then it became n by 8. So at each iteration the things were getting broken into half things. So log in for that, and for array each element was done for it, each element was iterated to it. So the time complexity became n log n. Log n is very famous number for programmers, because in every coding interviews you must be getting a solution which would be in either log n or n log n. So it's always better to get familiar with this term, because interviewers will, in 99% of the coding rounds, will be asking you to code a solution in n log n or log of n, whichever is possible. So yes, I think why it is n log n, it is clear to everyone, because it is actually a expansion of log n, which we have studied in our college or school. Okay, so will it be taking extra any kind, will it be in place or not? Tell me whether it will be in place or not. And one more thing, merge sort is very frequently used in many things. Whenever we have a very large amount of data and we want to sort it, it's very difficult to do things on a very large thing. But if we have a smaller thing, then we can apply our machines to solve. So what we are doing, we are basically breaking this into two half things so that it can be done faster. So even in our computers, for many operating systems, the things are broken into very smaller pieces, and then they are arranged on the basis of priority, so it is done faster. So there also we use basically merge sort in many operating systems coding. So merge sort is very extensively used, and it's always better to know merge sort whenever you are going to any coding interview, because in if any question is being asked from sorting techniques, 99% of the possibility is that it would be a merge sort problem. Whether it will be stable or not, one more question, whether it would be stable or not. And merge sort is not in place, right. Tehmid Imam Raud is right, it's not in place. And whether it's stable or not, one more question to you. After class, I'll share a document where I have written in handwritten format what is basically stability, what is in place, and there's a chart like which algorithm is what in term of time complexity, space complexity, stability, and in place nature. Okay, if these three coding sorting techniques are clear to you, I would move to another very famous thing, which is actually done whenever you use sort function. Have anyone used sort function in computer to sort any kind of array? I guess many of you must have used. In standard template library we have a word sort, and it automatically sort the array. So which sorting techniques do you think does it use? Anyone who can apply a guess to it? Which sorting algorithm is being used by sort word in standard template library of Java or C++? Which algorithm is being applied if you use sort? Okay, actually it's nothing, it's quick sort which is being used. Our quick sort algorithm is being coded, and we, whenever you call sort function, it automatically calls quick sort, and the things are being sorted. And it's a very, in starting, if anyone don't know what is quick sort, then it becomes a bit complicated, because here what we do, we have a array, right? If you have array, then first what we were doing, we were comparing things. And after comparing, what was happening, the biggest element was coming to last, right? We did that in one manner. We were choosing the minimum element, and then after one iteration, minimum element was coming to first. In one part, what we did, we divided the array into parts, and then made them in such a way that after joining them back, it becomes a sorted array, right? Now in quick sort, it's a different thing that we do apply to it. And here that thing is called pivot. uh, Here we have to choose a pivot. Pivot is nothing, pivot is actually a point where we have left thing, where we have right thing. It is actually a keel thing structure that you can imagine. We will be having things to left, things to right. And what we will do, we will try to arrange the other elements in such a way that, like for example, let me take a example. It's 9, 7, 6, 4 and 5. Okay, this is actually a array. Here what we do, we choose a pivot. Pivot is nothing, just any kind of element. And what element is being choose, it is chosen in such a way that if we choose 6, then any element coming to left must be smaller. What if 6 is chosen as pivot? Then we have to arrange the array in such a way that all the elements are smaller than 6 and all the elements to the right are bigger than 6. So in that manner, is 9 smaller than 6? No, then actually it is not a candidate to be chosen as a pivot. First we have to choose pivot point in it, that which number can be chosen as pivot, and then we have to sort the array in such a way that it becomes sorted. So first it, and one thing that I taught earlier, that if there is only one element, right, then it is always sorted, right? If we have only 5, then no need to sort it, it is always sorted. So what if we choose 9, like if we have this array in this way, 9, 7, 6, 4 and 5. If we choose pivot as 5, is there anything right to it? No. If there is nothing to write to it, then everything is sorted already. And if there is like left elements, then only those elements can be there which are smaller than 5. Then let me write it. Choosing cornermost element is always efficient as per as many programming books says, because in that way we have to do things only in one direction to solve it, right? So choosing a pivot in random way might create many problems to solve it. So what we do, we actually basically sort the things according to the pivot in left part, then in right part, and then we keep on sorting the array, and then for the next element it might be what next element, and it in final iteration it would be sorted. But actually this element this sorting algorithm is not that much famous, and it is not also that much being asked in many things. But we need to check it, like make it a habit to dry run this. So let me do this thing. If we have 1, 2, 3, 4, 5, because it is the best example to teach. So if we choose 3 as pivot, are the element to left sorted? Yes. 1 is smaller, 2 is smaller, this part is sorted. Are all the elements on right sorted? Yes. 4 is sorted, 5 is sorted. Then is this array sorted? Yes. Actually, this array is sorted. And what is done to it? Actually, quick sort is being called in two parts, and that is same as what is done in merge sort. So we call sorting into left part, we call sorting into right part. If we have chosen any pivot, we call function sort in left part, and we call function sort in right part. How many of you are comfortable in recursion? Are everyone? Hello. No, Python is actually not a programming language. It is a subset of language. So if you talk about any programming language as of C++ and Java, they use quick sort to sort things. Python is actually a library. And in Python also, there is no compiler. It's not a compiler that compiles the code. So in that manner, it's different thing. For C++ and Java, it's use this quick sort to sort things. Is everyone comfortable in right recursion? Because understanding of recursion is important in quicksort, and recursion in itself is a very big topic, because here recursively we will be sorting left thing and we will be sorting right thing, and in left part we will be choosing a pivot again, and then after choosing that pivot, recursion will be called to this part and recursion will be called to smaller part, and then later after when we have only one element they will be merged back, and this in this way this can be sorted. So I think if you have a better understanding of recursion, I can cover this in class, because it is very easy if you know recursion. Recursion actually is faith on coding what we are doing. In recursion, what we do, we basically break the problem into smaller pieces. Like if we have 1, 2, 3, 4, we will. I am taking sorted so it becomes easier to understand. So we have 1, 2, 3, 4, right? This is what, then we would again apply recursion to it and it would we have a faith, then if we apply recursion to it, then it will automatically return as the answer. So recursion is basically faith. We solve a very basic problem, like if there is a flood in any area and we are solving only problem of our locality, then we assume that the flood in all the locality will be gone. So this is done in recursion. We solve for 2 to 3 elements and we apply it for all, and then chain reaction happens and we get everything sorted. So this is what recursion is all about. And in basically quick sort, what we do, we choose a pivot, and after choosing a pivot, what we have left part, we have right part, we have pivot, then we apply recursion to this. So this is recursion, and in recursion we do the same step. In this part, left one, a pivot will be taken, then left part to it will be sort taken into consideration for recursion right part. Then for this left part, again we will have a pivot, this smaller recursion and this, and assume if there is only two elements, 1, 2, 3, 3 is pivot, 1, 2 is already sorted, then our problem is sorted. Then it will came back into this way through recursion and we will be having a sorted array. So basically quick sort is a very good example that I take to teach recursion, and I'll be covering that poor problem whenever I complete recursion. So let's take it to recursion part. If you talk about this, so now we have covered around 4 to 5 sorting techniques, and now I would like you to, whenever I would like you to take to a very famous question at last for sorting algorithm. Like if you have only 0, 1, and 2, and you need to sort it, which sorting algorithm would you apply to solve? If you have only 3 elements and you want to sort the array, for example, you have 2, 2, 1, 0, 0, 1, 2. This question is very famous. It's actually an algorithm and is asked for many coding companies. Which sorting algorithm would you apply to solve it? And how much time will it take? Anyone who want to give an attempt to it? There are only 3 elements, 0, 1, and 2, and you need to sort it. Which time? Okay, quick sort. Good. Any other sorting algorithm that you would like to apply to it so that it gets sorted? Like merge sort is always our solution, because in merge sort the average time complexity is O of n log n, right? N log n for merge sort. So if you apply merge sort, then time complexity of n log n can be applied. So our first answer becomes is merge sort, right? Because if you apply merge sort to it, it will at max take n log n time. And for many people who don't know, n log n is smaller than n square. I can prove it through a graph that n log n is smaller than n square. So n log n is better than n square in any testing scenario. Okay, one answer is bubble sort, but in bubble sort, our time complexity was n square, right? And if we can do things in n log n, then it would be very good for us. Okay, any other thing, any other idea that is coming to your mind? Because every time looks like it's not that problem, it might be a different problem. Any different technique that you think you can apply to sort it and you can get answer? In terms of sorting techniques, merge sort is the answer to it. Like merge sort can do it in the best time complexity at every case scenario. And what if the question was like you have to do it in such a way that only maximum amount of like comparison is only n, and then you need to sort it? Which sorting algorithm would be applied to it so that it gets sorted in? No, quick sort is not better for it. Three pointer approach, okay, very good. We would be applying three pointer approach to it. Like, and a bit of change to it, like if you are allowed to do only n number of comparisons, or basically n number of switches to it, which sorting algorithm do you think would be best for it, so that it maximum takes n number of swaps and number of comparisons? Yeah, great, selection sort. So I will take you back to that question. It's 2 2 1 0 0 1. Okay, what we can do to it, if we have this array, right, and merge sort is applied to it, I will sort it by merge sort today, and then we can take it to. So it's 2 2 1 0 0 1. Okay, right, not, no problem to it. Then in next iteration, what will it look like? It will look like 2 2 1. And in next iteration, it would look like 0 0 and 1. 1 is alone. Hereafter it would look like 2 2. 1 was alone. 0 0. So here 2 2, both are same, so no problem, sorted. 1 is alone, not a issue. Then after we have 2 2 and 1. Just wait a minute. So I don't think this is sorted manner. So what here it would look like, it was 1 2 2. Now come to this point, this is 0 0. After swapping 0 and 0, this is 1. After merging 0 0 1, then here after swapping, it becomes problematic. So our final array would look like, let me write the answer. So our final answer would look like 0 0 1 1 2 2. So our this answer will take n log of n. So according to a sorting algorithm, n log n answer can be done to it. But one of our viewers said that it can be done by three pointer approach. So what is three pointer approach? Actually, there is a trick to it. If we have only three elements, right? So what we can do, we need 0 at starting, right? Because 0 is the smallest element. Then 1 in between somewhere here in arrays, and then at last we need 2, right? If we have anything like this, then our array is sorted, right? So what we can do here, we can check for zeros in the array, right? If you have any kind of zeros, so let me take into 0 and 1 only for better understanding. If we have 1 1 0 0 1, right? So is this 0? No. Is this 0? No. Is this 0? Yes, it is 0. Swap it with first element. So 0 1, after swapping, we are swapping these two elements, right? So this has become 0, then it must become 1. 0 1. We were at this place. We got 1. No need to worry. Now next element is 0. Now again we have received 0, right? Now we need to swap it with the second element. Okay? So after this iteration, it will become 0 0 1. Now 0 and 1 were swapped, so 1 and 1. In next iteration we got 1. Yes. So this is already sorted, right? Are you getting my point? What I'm trying to do, I am taking one pointer at this point and one pointer to find where are zeros in it, and we encountered zero at this place, right? We found this is zero. So what we did, we immediately swapped it with the first identified place. So we found 1 0, we swapped, and then we again did this in this way to find this. Similarly, it can be done in this way. This is a homework to everyone. You can try it, it's very interesting. It's a very, very famous question to all. And when if you will do it, you will find it very fun to do this. Yes, the answer is in the comment section. Dutch national flag algorithm. This is what is thing. Yes, we can count 0, 1, and 2, and then we can try to do this. This is also right. But here we will be reading one additional thing. Yes, actually, it was very basic sorting algorithm thing. So we did it from very basic. We will try to cover most of the important famous questions. Those are also done on basic concepts only, but the way of asking them is a bit complex. So we would try to cover that in such manner that it can be done. So it would be a mix of both. Any other question that you want to ask from sorting algorithm? Because I would be covering this in my second day of lecture also in from depth. It was just a introduction thing so that you get introduction about sorting things and how things are done.
Amit, do you need your screen presented now? Like, will you be discussing any more
No, no,
topics?
no, no. For today I'm completed, so I have stopped sharing my screen.
Right. So, for those of you who are wondering what this second lecture will be, the link of the code, link of the course, is in the description, and you can check it out. Also, you can use this coupon to get a 20% discount on the course that is being offered, and you can just take a screenshot of this so that you don't miss it out. Just make sure when you use this code when you try to enroll in this course. And I'm sure, since Amit explained all this vastly today, I'm sure everybody will benefit a lot from that session, from that course as well. So thank you so much, Amit, for such an informative session. I learned a lot from you today. I already have my notes, and I'm sure I'll start working on them soon. So thank you so much, everyone, for joining us today, and have a great night ahead. Thank you, Amit.
Glad to have such a audience, great audience who participated, and thank you very much.